Okay, a warm welcome guys. In this video, I'm going to be teaching you how to do differentiation on TI84 Plus CE. So the step is pretty easy. You have to go to math and you see number 8 is in derivative. So just click number 8 and now you are in a differentiation equation. So in this case, you can input different numbers depending on your equation here. So most commonly it is dy dx, but it can be dy dA, b, c, d, dy du, blah blah, dy dy, something like that. So it's dy dx, so it's d dx, and if you enter, for instance, my example here is actually ax squared plus 5x plus 2, which is the example I'm using this video. And after I input all this, you have to input for what is x. So when you input x, basically when you're calculating the gradient of a slope, gradient of a parabola or gradient of a curve, you want to find the gradient at a particular point. So for example, if you want a x at 1 or x at 2, depending on your graph, so let's say x at 2 at this point. So the meaning of this is basically after differentiation, you will automatically set your data, substitute the data you enter here as x, and you will come out in a number. So if I click, you see number is 37. How did it come out? It's because when I differentiate, it will become 16x, isn't it? This will become 16x, this will become 5. So 16x plus 5, when we input 2, which is 32 plus 5 is 37. If you do the same thing again with a different number, for instance, it will actually show up different number as what you like. So for TI84, unfortunately, you always have to input a certain number, and the goal of this calculation is to give you a result rather than showing you 16x plus 5. So they are not going to show you the direct number or the variables in the equation form. You'll always give you a number, a natural number, to the result of your differential equation. So I also want to talk a little bit about integration. So this is only basic for the most part, but definitely it can be, it might be not helpful if you want to differentiate this particular thing just now, because this is pretty easy. You can do faster manually, but it is pretty useful when you are doing some integration with limit or differentiation with limit, or those trigonometric or exponential integrations or differentiations, which can take much longer time and there's much larger chance to make a mistake when you do it manually. That's when the calculator comes to be a large part. So for integration, if you can see, now it's n derivative, isn't it? There's also so-called integration. I think, yeah, it should be number 9, isn't it? Yeah, here's integration. So this is a definite integration, which means integration doesn't have plus c. So when you are integrating using TI84, you always have a number. For example, if you are doing like integration by part, or if you are just doing pure definite integration, you always have a number. For instance, here today I'll use 5 and 0. What does it mean for 5 and 0 is basically after your equation is integrated, you will sub 5 into x and 0 into x, and you will use 5 into the result after substitution of 5, subtract the result after substitution of 0 to give you a number. So there's no plus c because there's no indefinite number that we are not sure about. There's no constant number we don't know about in this equation. So for instance, we want to integrate the 37. So we want to integrate this equation. So let's just keep the same thing, so it'll be quite good. So for example, if I want to integrate ax squared plus 5x plus 2. So I want to use the same thing so you have a better look. So if now I integrate, you ask me d something, it should be dx. In this case, why is it dx? Because I'm using x inside here. So if I do dx, it will provide me with integration directly from this equation. But when you are doing at higher level math, maybe for year 11 or mostly in year 11, I would say maybe a little bit year 10, but mostly in year 11, you're going to be learning how to do integration by substitution for complex integral. So for complex integrals, you are not able to solve and integrate right away. You have to do some substitution. For example, those involving exponents, those involving square root, cube roots, or different power roots, exponential roots, all those involving sine, cosine, tangent, secant, and cosine, cosecant, and cotangent. Then you have to do use like a p, you have to do like a u, you have to use b in order to substitute some data, and in that case, it can be a little bit more difficult, it might be du. But in this case, like this pure integration, this basic integration here, we just keep it as dx. So now after that, we actually get our data. If you want to check your data, you can integrate this and sub in 5 and 0 to find the result. So now my result is 405. This basically means after I integrate this, I can show you how to integrate, but it's pretty easy. It is ax, this one becomes cube, you will divide by 3, this one will become square, you will divide by 2, this will become x. And after that, they will sub 5 into all x, I will get a number, and they will subtract the substitution of 0. So basically subtract 5x to be 5, subtract x to be 0. Then I'll get a result for integration. Okay, so I want to keep this video short and sweet. So this is basically how you do your basic integration and differentiation using the underiv and number 8 and 9. So you have underiv and f and t. So you have this two equation altogether. And remember, for differentiation, you have to enter x, and for integration, you have to enter your range, which is numbers for your definite integral. That is specifically important if you are taking MS in sort of a Cambridge. It is pretty important in terms of integration area by area, integration area by part, or like area under the curve. Yeah, so that's pretty much important there. So I'll see you in the next video. If you have any questions, please comment below, and hope this video can help to solve some of your doubts, and I'll see you in the future.